Hi everyone. So this is example 3 from the notes on section 2.7 and 2.8. And really this one example kind of encompasses all of lesson 2.8. So really what we're about to do is section 2.8 from your textbook. So in the last section we talked about how you can take data points and write variation equations to represent them. But it's important to remember that in real life, just like we talked about, data is not perfect in real life. Very rarely in real life is there only one factor affecting a dependent variable, okay? So this isn't one of those examples. We've got a construction worker building a board or a scaffold across two supports. So I'm going to do the best I can with a visual here. So here's your two supports, and then we're going to just build a board across that. And what I want to investigate is how much weight can that board hold? Oh, and it can't hold very much weight because I just broke it. But I'm ready for that. So I want to know how much weight can this board hold? And it depends on several different things, and all of this is written in words here, but it depends on, first of all, how far apart are my supports. If I were to put my supports closer together, then this board could probably withstand more pressure. Okay, it could take more weight. It also depends on how thick my board is. So if I build up my board to be a little bit thicker than it was before, then obviously it's going to hold more weight. Okay? And then finally, the width of the board. So if instead of using a really narrow one, I were to use a longer one like that, now you can't even see my supports, but that's going to hold more weight than the skinnier one. So all of those different factors affect my dependent variable, the maximum weight. Okay? And so if you really wanted to investigate this, what you would have to be careful to do is change one variable while holding everything else the same. And I sort of eliminated some of the words in your textbook. This had a lot of other explanation around these tables. But for example, let's say I wanted to know what impact does the width of the board have on the weight that it can hold. Okay, so really I'm investigating like this compared to this, okay? And obviously all different widths in between. I just don't have all the different widths. When I do that, I have to make sure that I hold all of the other things constant. So I have to keep my two supports the same distance apart, and I have to make sure that these are the same thickness, which they are. I don't know if you can tell that in the video, but these are the same thickness. So as I change from here to here, I need to make sure everything else stays constant. So when I'm looking at this, I'm assuming that all of those other factors are staying the same. And so the change that I'm seeing here in my maximum weight is only impacted by this one independent variable. Okay? And then same thing here. So here I'd be changing the thickness of the board, but I would be keeping the board the same width, and I would be keeping my supports the same distance apart. Okay? And then when I go to investigate the distance, I'd be moving those supports, further and further apart, but I would be keeping the width of the board and the thickness of the board the same. Okay? So what I want to do is, my ultimate goal is to write one equation that represents all of these things. Okay? And so we're going to start by writing one variation equation, just a general one. And this is nice. Remember, general means you don't have to find what k is. You still have to put it in your equation, but you don't have to find what it is. We're going to write one for each set of data, and then we're going to put this together into one monster equation that involves all of these independent variables. And actually today, that's as far as we're going to get, is just putting together that monster equation. And then tomorrow's lesson actually gets into, now how do you do math when you have all those different variables impacted, okay? So what I did, and I did some calculator trickery here just to save you some video watching time, is I'm going to type these into my list and take a look at them on the screen. Okay? So I already did the part where I hit Stat and Edit, and List 1, List 2, that should match this first set of numbers here. Okay? And now I just want to look at it on the graph because I want to know what kind of variation is this. By the way, I know already that it's some kind of direct variation because as this gets bigger, this gets bigger. Okay? So under my y equals, I want to make sure my plot 1 is turned on. And then remember, under zoom, you want to choose zoom stat, so it'll recenter on your new data. And I see this. And I think that's pretty safe to say that this is linear, right? That this is a linear function. And so my general variation function here, and I'm going to use letters that kind of represent these things, is my maximum weight is equal to k times, oh, I don't want to use w here. Let's just use d. Nope, I'm going to use d down below. Oh, sorry. We'll just call our maximum weight our y value. Okay, so I'm going to say what, sorry about that. I didn't think about letters ahead of time. So y equals k times w, where w is my width. Here I'm going to use t to represent thickness, and here I'm going to use d to represent distance. Okay, so this is the equation that matches this set of data, and again, this is assuming that these other things are held the same. Now I'm going to experiment and look at if I change the thickness of my board, what happens to my maximum weight. And so I'm going to go to my calculator. Once again, I'm going to do stat and edit. Here's list 1, here's list 2. Okay? And then I'm going to go to y equals. I'm going to clear out anything else that's there. Turn on my plot 1. And then I do have to do zoom stat again, okay, to be able to see my picture. Now see how that one has a little bit more of a curve to it? That's still direct variation because I can still see when this is getting bigger that this is getting bigger, okay? But this one's taking on more of a curved shape to it. So I want to make sure that I don't just do k times whatever. This time it's going to be y equals k times t squared, because this is clearly a half of a parabola that I'm seeing. And that's this type of variation. Okay. Now when I go to do this third one, same thing, except this time I do notice that as my distance between the supports is getting bigger, the weight that I can hold is actually getting smaller. Okay. And hopefully that makes sense to you, that if I am increasing the distance, if I'm pulling these further and further and further apart, my board is going to be able to hold less and less and less weight. Okay. So that's what that's really saying. So when I look at this one on the graph, again, I went stat and edit. Here's list 1, here's list 2. Go to y equals, turn on plot 1, zoom and stat. Okay, I definitely have a hyperbola going on, which I knew because it was going to be inverse. Our question is it inverse or inverse square? I guess really we should plug numbers in and check. Let's see. For our purposes right now, we're going to be doing enough plugging in. The reason I'm saying this is today we're not plugging any numbers into anything, at least for this portion of the lesson. When we get to tomorrow's lesson, we will be. So let's just save that for tomorrow. For today, I'm okay with you just saying we know that's k over, what am I calling this, d. And it's possible that that's d squared, but we would find that out when we actually went to plug numbers in. Okay, and we're not doing that right now. So we're just going to leave that like that. Okay, so the thing is, each one of these k values, even though I used k for all of them, these would all be different k values, okay, because there's a different relationship between the distance and the weight than there is between the thickness and the weight, okay? So instead of solving for multiple k values, what I'm going to do is I'm going to combine all of these into one like monster mutant equation, okay? And here's how that's going to go. I'm going to start with y equals, okay? And I know I'm going to have a k, all right? And this k is different than all of these other k's. If I actually figured it out numerically, they would all be different, okay? My k needs to get multiplied by w based on this first equation. So I'm going to go ahead and multiply by w. I also need to multiply by t squared. So I'm going to go ahead and just multiply that by t squared. And then I need to divide by d. So I'm going to take this entire thing and divide by d. And so this right here is my general relationship between all of these variables, okay? Now, I could plug in one set of values for W, T, D, and Y, plug in numbers everywhere, and solve for K. We're going to get to that tomorrow, okay? For today, this is what you need to be able to do, is write these individual equations and then go ahead and combine them into one big mutant equation. And what I kind of say is, when you're done, if you want to just check and see if you put it together correctly, you should be able to find each one of these in the equation if you cover up the other variables. So for example, K times W, if I cover up T and D, I have K times W. For my T, if I cover up W and D, I end up with K times T squared, which is what I had up here, okay? And then if I cover up W and T, I end up with K over D, which is what I had in this last equation, okay? So that's what you really need to be able to do today. And then again, we're going to kind of jump in right here on Friday and talk about now how do we actually write this with numbers and use it to make predictions and things like that, okay? But today the goal is just to be able to do this, do this, and then do this, okay? So section 2.8, I don't think you have very much assigned to out of section 2.8, but it's mostly going to be questions along these lines, okay? And we will go over this in class tomorrow.